All right, here we go, Math 2. We've got lesson 5.1.2, multiple representations of quadratic functions. So we're going to still look a little bit more at our graphs and see if we can learn a little bit more about the relationship between the equations and the graphs that we're making. So to start this off, we've got a situation here. Every year at the homecoming game, there is a contest to use a slingshot to launch a water balloon on the football field at halftime. The longest distance and highest launch both get prizes, and they use a computer to measure the trajectory of the balloon. It uses X to represent the horizontal distance, so how far it's traveling side to side, and Y to represent the height of the balloon in yards. For each contestant, create a table of data and graph each launch. So we're going to do that on the resource page that we've got right here. So we've got our water balloon contest, and we're going to graph each of them in a different color. Looks like we've got 4 people to deal with here. All right, so contestant number 1, Maggie places her slingshot on the 3-yard line. So she's going to start on the 3-yard line. We're going to make her pink today. So here's Maggie. She places her balloon right here on the 3-yard line. So that's where she's going to start. So Maggie looks like she starts at 3, 0 for that one. All right, then what else happens? And then the computer reports the balloon traveled along the parabola represented by this equation, negative x squared plus 17x minus 42. All right, so her equation is negative x squared plus, what's that, 17x? Plus 17x minus 42. All right, what we learned in the last section is that when we have a negative out front here, that parabola is going to face down, which makes sense because this means that this is going to go up and then come back down. Okay, so let's just go ahead and plug in some numbers here and see what we get. Since we already have 3, let's plug in 4. So I'm going to plug in 4. 4 squared is 16. Then this makes it negative, so that's negative 16. And then 16 times 17. Oh, we're going to have to do some math on this one. Let's work. All right, sorry, I had to go get a calculator. All right, so negative 16, no. Oh, 17 times 4. I didn't need it. So 34, 68. So we get 68 and then minus 42. All right, so working this all out, that's 58, so 10. All right, so my next point is at 4, 10. Got it. Okay, so next one I'm going to plug in 5, see what happens. So I plug in 5, I get negative 25, and then plus 85 minus 42. All right, and looks like it hit 18. All right, so at 5 we get 18. 1, 2, 3, right here. All right, so we can kind of see that shape starting now. It's starting to slow down in the speed that it's going up. All right, so we got to keep going. So we'd plug in 6. If I plug in 6, I get negative 36 plus 102 minus 42. All right, and that comes out to, oh gosh, that comes out to 24. All right, so 624 will be right here. We can definitely see it's starting to slow down now. It should be getting close to the top of the parabola, but it's not quite there. So we're going to plug in 7, 8, 9, 10, and 11. All right, I'm going to pause this and do all the calculations. You can do it too. See if you get what I get. All right, I finished working it out. It looks like it makes it up to 830, and then 9 feet away it's at 30. So it looks like my vertex has to be in between those 2 points. So my vertex should be at 8.5. So 8.5 is my vertex. So real quick, I'm going to plug in 8.5 into this equation. and I get 30.25. All right, so let's go ahead and graph the rest of this out. So we've got, we ended with 6. At 7, we've got 28. So 728 is going to be here. Next point is at 8:30. 8:30 is here. And then we saw that it started coming down at 9:30 right there. All right, and then we said, okay, our vertex has to be in between these 2 points. That would be at 8.5, and we got 30.25. So that's this point right there. I'll call that 30.25. Now, I don't really have to plug in the rest of it because I know where my vertex is. And so with the axis of symmetry, or the line of symmetry, I can finish off the rest of this graph. I can do that just by going, okay, it's going to be a reflection. So this is reflected over there, so this one has to be reflected over here. This one has to be reflected over to here. This one has to be reflected over to here. This one is reflected over there. And now we see where it's going to hit the ground. It's going to hit the ground here at 14. So that's the nice thing about once you find your vertex, all these other points, you don't actually have to plug them in because they're going to be reflections of these other points because of the line of symmetry. So I graph this thing. I'm going to make my graph continuous because this water balloon is always going to be somewhere in the air. It's not going to teleport. I hope. Oh, this is hard. All right, so, oh, that doesn't look good. But we're going to just go with it and say, hey, yeah, that looks great. So I can see here that her highest point is up here at 30.25. All right, that's our first person, second person. What happens? Contestant 2. Jen places her slingshot on the goal line, and the computer reports the balloon's path with the graph shown at right. Oh, well, why didn't they just put that on the other paper? I don't know. So let's go ahead and just use these numbers and put it in a table. So it looks like we've got 0, 0. So she starts where she's supposed to start at the goal line. So we got 0, 0. Next point looks like it's at 1:14. Next point 2 is at 24. 3:30. 4, there's the vertex. 4:32. All right, now the nice thing is, now that we found that vertex, everything should be a reflection on the other side. So 5 should be 30. 6 should be 24. 7 should be 14. And we can see that it's going to hit the ground at 8 because it'll be 8, 0 right there. All right, so let's go ahead and graph that. 0, 0, 1:14, 2:24, 3:30, and then our vertex was at 4:32, and then it makes a reflection on the way back down. Looks like they collide right there. And we said 8, 0 would be this point. So yeah, that looks about right. So here's my vertex way up here. Comes back down. Good enough. All right, so there is Jen's toss. All right, next one, Imp. Is there a person's name? God, person's name is Imp? A horrible parents named a kid that. Imp launched their balloon and it hit the computer and we were only able to receive part of the data for the launch, which shows the table. If it hit the computer, shouldn't it just hit the ground right away? I don't know, we'll just suspend belief and just think, okay, I can see my vertex. See this right here? Change colors. Let's do green. This has to be my vertex because look, on either side, they're the same number. All right, so we're just going to graph these people and we're going to be able to tell where it's going to hit because this number is the same as this number. This number should be at 10. So 10, 16 should be a number. This number here should be 11, 9. And it looks like at 12, 0, that's when it hits the ground again. So knowing where your vertex is, you can just find all these other values without having an equation. So let's go ahead and graph all those values real quick. So this is IMP's toss. I don't know where they came up with that name. So they start at 2, 0. So he's cheating. 3, 9. 4, 16. 5, 21. 6, 24. Dang. They're all hitting that one spot. And then 25 is our highest point, 725. And then everything else is a reflection at that point. So I'm just doing reflection across, reflection across, reflection across, next reflection across, next reflection across. And over here at 12, they're hitting the ground. All right, so there you go. There's IMP's. His definitely did not go the highest. So far, looks like Jen's going the highest. IMP, not so good. All right, last person, contestant number 4. We've got Al. Al launched his balloon at the 10-yard line, and it landed at the 16-yard line. With the computer broken, we had to estimate the height, and we guessed it was 27 yards. All right, so we're saying that he launched it at the 10-yard line. So here he is launching at the 10-yard line, so he's on the ground there. Then it says that, stupid things, it hit the ground right here. And then, let's see, we guessed that the height was 27. Now, since these are the two y-intercepts, the vertex has to be directly in between them, so at 13. So 1327 has to be the highest point. So I'm going to go 13, 25, 26, 27. There's his highest point right there. So it looks like, since these are the intercepts, that right in between them, that has to be the axis of symmetry. And the vertex is always on that axis of symmetry. So I don't know exactly what this one looks like. Just going to guess it. And there's the last person's. All right, so let's see if we can answer our questions at this point. So it said earlier that we're doing a contest and blah, blah, blah. Longest distance and highest launch get the prizes. So we can see here who has the highest launch. The blue line does. That's Jen. She gets the highest launch. That's at the vertex. And we saw that her vertex was at 32. So Jen has the highest launch. Because her maximum value was 32. All right, and now we're going to see who went, who went the farthest? Yes, the longest distance. This would be side to side. And it looks like, let's see. It looks like, yes. So if we're looking for longest distance, this person went from 0 to 8. That's a distance of 8. So Jen is going 8. Green, that was Imp. He's going from 2 to 12. That's a distance of 10. So Imp's went longer. And then the pink was Maggie. Maggie's going from 3 to 14. That's a distance of 11. And Al went from 10 to 16. That's a distance of 6. So it looks like Maggie's toss went the longest distance. It went from 3 yards all the way over here and landed at 14 yards. So she has the longest distance. Yay, we did math. All right. Oops, wrong one. Last thing that we're going to do. Write an equation for the tile pattern below. This is kind of a little bit weird, but let's look at what's the same in the tile patterns and what's changing in the tile patterns. So I can see here that this and this look to be the same every single time in my tiles. So in my tiles, if y is the number of tiles and x is the figure number, so we're going to say x is the figure number and y is the number of tiles. Now on this one, we can see here in figure 1, we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 tiles. In the next one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The last one, we've got 1, 2, well, this is 4 by 5, that's 20, so that's 22. All right, so I can tell this is not linear because we're not adding the same amount each time. So from here to here, we're adding 6, and from here to here, we are adding 8. So we're not adding the same amount each time. So how are we going to write an equation that's not linear for this one? Well, what we can do is we can look at it as two different things. Number one, like we said before, we've got some things that don't change. These two are always there. So my equation should have 2 that are always there. That represents these green ones that are always there. Now the rest, since we're talking about kind of like rectangles here that are being formed, the number of tiles in this rectangle can be shown by length times width. Now this one has 2 times 3. So this one is y equals 2 times 3 plus those 2 green ones there. This one, this is 3 and 4. So this one is y equals 3 times 4 plus the 2 green ones there. And 3 times 4 is 12. 12 plus 2 is 14. So that's making sense. Now this one is 4 times 5. So this is y equals 4 times 5 plus 2. Stupid bills. Now what I do notice here is comparing the figure number, this is 1 more than the figure number, this is 2 more than the figure number. When we have figure 2, this is 1 more than the figure number, this is 2 more than the figure number 2. Figure 3, 4 is 1 more than 3, 5 is 2 more than 3. So we do see our pattern there. What's happening is this number is 1 more than the figure number, x. This number is 2 more than the figure number. The figure number is x plus 2. So when the figure number is 1, this is 1 plus 1, that's 2. This would be 1 plus 2, 3. When the figure number is 2, this is 2 plus 1, 3. This is 2 plus 2, 4. So there I'm seeing my pattern. I always am doing this rectangle's area to find out the number of tiles there. And it's 1 more than the figure number for the length. and it is 2 more than the figure number for the width. So my equation would be y equals x plus 1 times x plus 2 plus the 2 green ones that are always there. Now we could simplify this. If you do an area model with this, you would get x squared plus 3x plus 2. And then we could combine these last two like terms. And we get an equation of x squared plus 3x plus 4. And if I plug in figure 1, we get 1 plus 3 plus 4. Yep, that's 8. If I plug in 2, I get 4 plus 6 plus 4. Yep, that's 14. If I plug in 3, I get 9 plus 9, 18, 19, 20, 21, 22. I get 22. So that is my equation for that. All right, that's all I got for you today. Math hard. See you later. Bye.